Welcome back. Today we are starting Chapter 4, Linear Equations and Their Graphs. Let's look at the overview of this chapter. We have 5 main sections, from the coordinate plane to inequalities. In this specific lesson, we will focus on Section 4.1, the coordinate plane, and Section 4.2, lines. Let's get started. A plane is a flat surface that extends indefinitely in all directions. To locate points on a plane, we draw 2 perpendicular number lines. The horizontal number line is the x-axis, and the vertical number line is the y-axis. Their point of intersection is called the origin, and points are located using an ordered pair of coordinates. Let's look at example 1. Plot the coordinates 4, 2 on a graph. The first number 4 is the x-coordinate, representing the horizontal distance from the origin. So, we count 4 units across to the right on the x-axis. The second number 2 is the y-coordinate, representing the vertical distance. We count 2 units up parallel to the y-axis. Let's follow the dashed lines from the axes. Where they cross, we place our final solid point and label it as 4, 2. This beautifully defines our position on the plane. Sometimes we need to plot more than one point. You can often join up several plotted points to create the outline of a geometric shape. By connecting consecutive points, we can form polygons and calculate their dimensions, such as the lengths of their sides and their total perimeter. Let's solve example 2. Plot and label the points M, 4, 2, A, -4, 2, C, -4, -2, and V, 4, -2. Connect the points and find the perimeter of the resulting quadrilateral. First, let's locate each vertex on our coordinate plane. Counting the grid squares, the rectangle has a length of 8 units horizontally and a width of 4 units vertically. The perimeter formula is 2 times the length plus 2 times the width. This gives 16 plus 8, which simplifies to a final perimeter of 24 units. The coordinate axes divide the plane into 4 regions called quadrants. The quadrants are numbered counterclockwise using Roman numerals. The signs of the coordinates differ from quadrant to quadrant. Let's learn the sign rules for all 4 quadrants. Let's examine each quadrant on the grid. In quadrant 1, on the top right, both x and y are positive. Moving counterclockwise to quadrant 2 on the top left, x is negative and y is positive. Quadrant 3, on the bottom left, has both x and y as negative numbers. Finally, quadrant 4 on the bottom right has a positive x and a negative y. Simply by looking at the signs of the coordinates, you can easily tell where a point lies. Some points in the plane lie directly on the coordinate axis. All points whose coordinates are in the form x, 0 are located on the x-axis. All points whose coordinates are in the form 0, y are located on the y-axis. If neither coordinate is 0, the point lies in one of the quadrants, not on an axis. Let's solve example 2. State which axis, if either, these points lie on. For A, the point is 0, 4. Since the x-coordinate is 0, it lies on the y-axis. For B, the point is 7, 3. Since neither x nor y is 0, it is not on an axis. For C, the point is 8, 0. Since the y-coordinate is 0, it lies on the x-axis. A straight line extends indefinitely in opposite directions. Lines have no endpoints, meaning they have no beginning or end. They have infinite length and no thickness. To draw a straight line, you simply need to plot 2 points on it and connect them. Let's look at example 1. Draw the straight line defined by the points -3, 1 and 3, -1. First, we plot the 2 points on the coordinate plane. Then, we connect them using a straightedge. Notice the arrowheads at both ends of the line. These show that the line continues indefinitely without ending. A straight line can be described mathematically by an algebraic equation. All the points that lie on the line have coordinates x, y that satisfy this relationship. For instance, an equation defines how to find the y-coordinate for any given value of x. This rule is called the equation of the line. Let's solve example 2. The points on the line y equals 3x plus 2 are defined by the form x, 3x plus 2. Find the coordinates of the points where x is a member of 0, 1, and 2. We substitute each value of x into the expression. When x equals 0, the coordinate is 0, 2. When x equals 1, we get 1, 5. And when x equals 2, it becomes 2, 8. So the resulting coordinates are 0, 2, 1, 5, and 2, 8. Points with the same x-coordinate are all the same horizontal distance from the y-axis. Therefore, a set of points that all share the same x-coordinate will fall on a vertical line. The equation of a vertical line is written as x equals c, where c is a fixed constant number. On this line, the x value never changes, regardless of what the y-coordinate is. Let's look at example 1. Draw and label the vertical lines x equals -2 and x equals 3. For the line x equals -2, we find -2 on the x-axis and draw a line straight up and down. For the line x equals 3, we find +3 on the x-axis and draw another vertical line. Notice that while the y-coordinates are completely different for each point on these lines, the x value stays exactly the same all the way through. The equation of a horizontal line is written in the form y equals c, where c is a constant fixed number. On a horizontal line, the values of the x-coordinates are completely different for each point, but the values of y stay exactly the same all the way through. Let's look at example 2. Draw and label the horizontal lines y equals 3 and y equals -2. For the line y equals 3, we find +3 on the y-axis and draw a straight line left and right. For the line y equals -2, we find -2 on the y-axis and draw another horizontal line. Notice that while the x-coordinates are different for each point on these lines, the y value remains completely unchanged. An equation in two variables x and y is linear if the variables have an exponent of 1. It can be written in the standard form, ax plus by equals c. The solution set consists of all ordered pairs x, y that satisfy the equation. All the points in this solution set lie on a straight line, which forms the graph of the equation. Let's explore the graph of the linear equation 3x plus 2y equals 6. To find points on this line, we can search for ordered pairs that make the equation true. For example, let's test the pair 0, 3. 3 times 0 plus 2 times 3 equals 6, so it is a solution. Next, let's test 2, 0. 3 times 2 plus 2 times 0 equals 6, so it is also a solution. When we plot these points and draw a line through them, we get a beautiful straight line. To determine if a point lies on the graph of an equation, we substitute the x and y coordinates into the equation. If the substitution results in a true statement, the point lies on the graph. If it results in a false statement, the point does not lie on the graph. Let's solve example 1. For a, we substitute 3 for x and -2 for y into the equation x minus 4y equals 11. This gives 3 minus 4 times -2, which simplifies to 3 plus 8 equals 11. Since 11 equals 11 is a true statement, the point 3, -2 lies on the line. For b, we substitute -2 for x and 3 for y into 3x plus 2y equals 5. This gives -6 plus 6 equals 0. Since 0 does not equal 5, it is a false statement, meaning the point -2, 3 does not lie on the graph. To graph a linear equation using 2 points, first rearrange the equation so it is in the slope-intercept form, y equals px plus q. Next, choose 2 values of x and substitute them to find the corresponding y values. Plot these 2 points and draw a straight line through them. Finally, choose a third point to check that your line is completely correct. Let's solve example 1. Plot and label the graph of the equation x minus y equals -2. First, we rearrange this equation to get y equals x plus 2. Let's choose 2 values of x. When x is -2, y is 0, giving the point -2, 0. When x is 3, y is 5, giving the point 3, 5. Let's plot these and draw a straight line. To check, let's use a third point where x equals 1. This gives y equals 3. Since the point 1, 3 lies perfectly on our line, our graph is completely correct. If a point lies on a line, then its coordinates must satisfy the equation of that line. This means if you substitute the coordinates for x and y into the equation, it will make a true mathematical statement. We can use this property to calculate unknown values, such as finding a missing variable k. Let's solve example 1. The point 3k, 2 is on the line x minus 2y equals 8. Find k and justify your answer. First, let's substitute 3k for x and 2 for y into the equation. This gives 3k minus 2 times 2 equals 8. Simplifying the multiplication, we get 3k minus 4 equals 8. By the addition property of equality, we add 4 to both sides, which gives 3k equals 12. Finally, dividing both sides by 3, we beautifully find that k equals 4. So, the actual point on the line is 12 too. We can also use the coordinates of a known point to identify an unknown value in the equation. Even if the question looks a bit different, the core mathematical method remains exactly the same. Simply substitute the given x and y values into the linear expression to solve for the missing coefficient b. Let's look at example 3. The point 2, 1 lies on the line bx plus 2y equals 8. Find the value of b. To solve this, we substitute 2 for x and 1 for y into the equation. This gives b times 2 plus 2 times 1 equals 8. Simplifying the expression, we get 2b plus 2 equals 8. Subtracting 2 from both sides gives 2b equals 6. Finally, dividing by 2, we find that b equals 3. Therefore, our complete line equation is 3x plus 2y equals 8. The x-intercept of a graph is the specific point where the line crosses the x-axis. Every single point on the horizontal x-axis has a y-coordinate of 0. Therefore, all points on this axis are always written in the form x, 0. To find the x-intercept from any linear equation, we can simply substitute y equals 0 and solve for x. Let's solve example 1. Find the x-intercept of the line 4x minus 3y equals 12. Since we know the x-intercept always has a y-coordinate of 0, we let y equal 0. Substituting 0 into the equation gives 4x minus 3 times 0 equals 12. This simplifies directly to 4x minus 0 equals 12, which means 4x equals 12. Dividing both sides by 4, we find that x equals 3. Therefore, the coordinates 3, 0 define the exact x-intercept of this line. Since the y-intercept has an x-coordinate of 0, we can always find the y value by letting x equal 0 in the equation of the line. Every single point on the vertical y-axis has an x-coordinate of 0. Therefore, all points on this vertical axis are written in the form 0, y. Substituting x equals 0 simplifies the linear equation, leaving only the y variable to solve. Let's solve example 3. Find the y-intercept of the line negative 3x minus 4y equals negative 12. First, we let x equal 0, then solve for y. Substituting 0 for x gives negative 3 times 0 minus 4y equals negative 12. This simplifies directly to 0 minus 4y equals negative 12, which means negative 4y equals negative 12. Dividing both sides by negative 4, we find that y equals positive 3. Therefore, the coordinates 0, 3 define the exact y-intercept of this line. To graph a straight line by computing the intercepts, first find the x-intercept by letting y equal 0, then solve for x. Next, find the y-intercept by letting x equal 0, then solve for y. Draw a set of axes, plot both intercept points, and draw a straight line through them. Finally, verify your work by checking a third point on the line. Let's solve example 1. Draw the graph of 3x plus 4y equals 12 by computing the intercepts. To find the x-intercept, let y equal 0. This gives 3x equals 12, so x equals 4. Our x-intercept point is 4, 0. To find the y-intercept, let x equal 0. This gives 4y equals 12, so y equals 3. Our y-intercept point is 0, 3. Let's check using a third point. If x equals negative 4, substituting it gives y equals 6. Since the checkpoint negative 4, 6 lies perfectly on our path, the line is absolutely correct.